All right. Okay. Well, welcome back to school, everybody. It's very exciting. Is everyone here a senior? Who's not a senior? Who's not a senior? Anybody? Okay. Okay. A handful of you. All right. So you guys got in, but the rest of you guys are seniors that will graduate in spring quarter. Is that right? Okay, so that's very exciting. So if everything goes according to plan, we'll see you guys. I don't know what's up with my mic. Graduation ceremony in, I guess, 9 months. Okay, 3 quarters away, and then the rest of your life. Okay. Okay, see, this is our Python class, Stats 131. It's a new course. I mean, relatively new. This is the 4th time we've offered it. And but the very first time was spring 2018. Okay, so we had spring 2018, fall 2018, spring 2019, and now it's fall 2019. Okay, and each time I've done it, I've made some iterational improvements and things, and probably so spring 2019, I feel like things went pretty well, and so probably I will try to stick to a similar plan to what I did in the spring quarter of this year. So anyway, we are learning. We're going to cover Python, but as well as a few other things. Notably Git and SQL, and I guess we'll interact with Python via the Jupyter Notebook. Maybe you have requests for other stuff, but this is kind of what I'm looking at. All right. I don't know what's up with the this purple projector. Okay, so you might have to look at the other one. But so this first, first week we'll look at Git in GitHub. Okay. Then we'll start looking at Python and NumPy and Pandas. Okay. I want to make it clear that this is not a Python programming course. Okay. So we're not going to be learning like kind of Pythonic algorithms and Pythonic stuff, and this is very much, we're learning Python for the intent of analyzing data. Okay, so we're going to learn how to kind of manipulate data and summarize data, create graphs from data, and do that kind of analysis. That's what we're going to be doing in Python. We will touch a few scikit-learn stuff, so that's like machine learning stuff with Python, a few of those things. But again, this is not Python programming. It's not like the PIC series or a CS course. This is very remote from that. Also, as far as on the spectrum of courses go, there's courses that are more theoretical and courses that are more practical, right? And this is definitely on the practical side. So we're going to be learning, kind of what I think is relatively current stuff that people do in Python and Pandas and things like that. I'm kind of at a basic level, obviously. Anytime you do something practical in a computer programming environment, chances are in a few years it's going to be outdated. Okay, so you'll have notes and stuff from here, but in a few iterations, there'll be newer versions of all of these packages. Some of these things that we've learned might become deprecated and things like that. So Python is a language that has a very active kind of base, and they frequently update the kind of the functions that get used. And so, so there's especially, I guess, a strong warning that what you learn today might evolve and change over the next few years. Okay, it's just kind of the nature of that. Okay, there will be a midterm kind of exam, but there's no final exam. Instead, we're going to have projects and presentations. Okay, and so there's 80 of you enrolled, and so I'm gonna have you guys. I'll set up a page somewhere, but at some point you're gonna form groups of about 4. Okay, groups of 4, and you'll do projects. Okay, in your groups. Okay, and it's gonna be basically a data analysis project. You'll find some data and you'll do some analysis there, and then we'll have you will schedule 2 meetings with me. Okay, one meeting to kind of give me a proposal of what your data is going to be and what your project's going to be about, and then the second will be for your final presentation. And we're going to do presentations during all of week 10, and we'll have a schedule to sign up and do your presentations. And those are generally this is about how much time I needed in the spring, about 50 minutes per group. Okay, I'm going to sit. So the group presents for about 5 minutes, and then I ask questions for about 45 minutes. So, and that's how I do my evaluations. All right. But I think it worked well. Okay. And okay. So anyway, this is how the grade breakdown will go. I just sent out invitations to DataCamp. I don't know if you guys got them in the last hour or so. Okay. I'm gonna put up assignments via DataCamp. DataCamp is a website or a company that has these little training modules and things like that. And so you'll have homework there. I'll also have my own homework assignments, and then we'll have a midterm exam and final project and stuff like that. Okay. I'll set up a campus wire thing as well. Coding, learning a language, code and stuff is very much like, I think my analogy is to compare it to playing a sport or going to the gym or something like that, where the more you put in, the more you're going to get out. Okay, if you just do the bare minimum, okay, like I give homework assignments and stuff like that, and if you just do the bare minimum, you'll get the bare minimum out of the class, which is you'll get like a very basic grasp of doing data analysis with Python. Okay. I also want us to be realistic about our expectations for what can be achieved in 10 weeks. Okay. I don't think it is even possible to go from no Python to expert in Python in 10 weeks, even if it was like your full-time job where you spent 8 hours a day or something for 10 weeks. It's just too much, okay? And we're not even going to do anything that approaches that. Probably, realistically, between the DataCamp assignments and the homework assignments, realistically, maybe about 5 hours to 6 hours a week or so, okay? And so at the end of 10 weeks, you can have about maybe 50 to 60 hours of Python coding experience or something like that, okay? A lot of you guys are thinking about getting jobs and applying, and you want to be able to put Python in your resume. I would hesitate to say, like, if you just write proficient in Python, okay, proficient in R, proficient in Python, these are very loose vague words, okay? Proficient in Python can mean like a lot of things, and so I would encourage you to write something a lot more tangible and specific. Okay, right? Say 50 hours coding experience in Python, 100 hours coding experience in Python. 200 hours coding experience in Python, or something like that. Okay. Now, obviously, if you only did the bare minimum, don't write 100 hours coding experience in Python at the end of the course, because that's probably not going to be true. But so anyway, think of it that way. Let me just let's go over to DataCamp. Okay, so you'll log into DataCamp. Let's see. I think so. I've sent out invitations. Okay, so a lot of you guys have, and I think I've got one assignment on here. Okay, so your very first assignment is going to be Introduction to Git for Data Science, and if you go to DataCamp, you can do this, and you will do your activities through here. Okay. I just reset my progress and whatnot, but you'll you'll be able to do your assignment, complete the work, and then you get these nice little I guess statements of accomplishment. Because I've invited you, so DataCamp has given all of you free access to their premium product for 6 months, which I think is like I think it's normally $30 a month. So it's like 180 bucks in value to their website, which is really nice. So you have access for 6 months, and I think the access started, I want to say September 23rd. So I think through March 22nd or something around there. Okay, March 21 is when it's going to expire. So the first day of spring, I guess. And so, you are not restricted to just what we have in the course. Okay, I will create assignments, and you'll have to do those to get credit for them in the class. But you are also welcome to, I guess they have 304 different courses in R and Python and all sorts of other stuff, and you can click any of these things, and you can do the exercises. They also have something called tracks, learning tracks, okay? And you can click like a career track or something. And I think if you do something like, data scientist with R or something, it will have something like 22 courses listed. And each course is probably around 4 to 5 hours of work. And so you can work through all of that and whatnot. So they're all overall. I've been impressed by the quality of the courses at DataCamp. Okay. That said, okay, the DataCamp exercises are very structured. Okay, and a lot of them are kind of set up in such a way where you are going to be kind of filling in the blank, okay? And so the regular mode is to just do the exercise, you fill in your answer, and then you move on and things like that. If you want to put it in hard mode, okay, what you can do is you can delete, when you get the script, you can kind of take a glance at it, okay? So there'll be a script where there's blanks for you to fill in, okay? And hard mode, if you want, is you can kind of look at that, then delete everything, and then see if you can kind of rewrite the script yourself, okay? And because, with the fill in the blank nature, it's not very easy, but it's pretty easy. It's pretty well defined, okay? If you take a look at it and then delete it, okay, it's gonna make your homework take like twice as long, okay? So just word of warning, it's gonna take you twice as long to do your homework, but it will force you to kind of think, and you've got a preview of what it looks like, but it will also force you to kind of make sure you write the code yourself, okay? These are just different things. Okay, as far as the DataCamp homework goes, DataCamp only has 3 statuses for the homework. So normally for my regular homework, I have like this, like you get a grace period, and then each hour it's late counts, deducts a certain thing. But DataCamp, it's either you finished it on time, you did not finish it on time, or you did not do it, okay? And so I can only kind of record the grades as such as well. So you'll either get 100% if you finish it on time. If you finished it late, I'll do 70%, and then if you didn't finish it, you're gonna get a 0, okay? So I'll have the kind of the full listing of courses that I'm going to require you to do on DataCamp, and so I'll put that under I guess site info. I'll put the full homework listing here, and then I'll make all of the assignments on DataCamp as well. Okay, so sign up for that and do that. Okay. Okay. Any questions regarding the syllabus? Let's see. Okay. We'll have a midterm exam, I guess, during 7th week, and it's going to be. I have to probably fix this, but it'll be during. It's going to be a take-home exam, and take-home exams are always a little bit risky, but I think I'm hoping the pressure of the exam and the time constraint will keep you guys honest. And so 7th week Friday, we'll have an exam from 3 to 5 p.m. Okay, so we're not going to come to this classroom. Okay, you stay home wherever you are. Okay, and then and I'll post the post kind of this project file for you to work on, and then you'll do the analysis there. Okay. All right. Okay. So we're going to start off this first week covering Git and GitHub. Okay. So Git is a version control system, and GitHub is kind of this, I guess, collaborative server that you can host repositories and whatnot on. With part of this first assignment is that you're going to have to create a GitHub account and create your own repository and whatnot. And I think this is going to be very good for anybody who's going to seek employment that involves any kind of coding. Okay, so if you're going to seek a job where you're expected to do data analysis, data science, or any kind of coding, a lot of times your employer will want to see some of the work that you've done, okay? And let me tell you, and so I think GitHub is kind of the natural place to share your code and let people see what you have done. Please do not upload your homework assignments to GitHub, okay? First of all, no employer is impressed if you tell them I did my homework, okay? If they say, all right, what kind of stuff have you done? What kind of coding projects have you done? No one's going to be impressed when you say, I did the homework that was assigned to me. The homework that was assigned to everybody in the class and required of everyone to complete. I did the same thing that everybody else did, okay? This is not going to impress anybody. So it's not like, please don't upload your homework solutions for any of your 102A classes or whatever onto GitHub. Employers are not going to be impressed by it, and then it creates problems, you know, the dean of students and stuff like that. So don't do that, okay? What you want to do, all right, is you want to think of something new, right? Go on a site, find some data, do a data analysis. Hopefully by the end of this course, you'll know how to do some data analysis in Python, and do it, write a report or something, and share that to GitHub. Do something that nobody told you had to do, and if you go out and do this I think shows the employers you know, initiative and kind of your passion for the stuff, okay? Your interest, and it also show off your skills, okay? And that's I think what employers will want to see, all right? A lot of times people will say, oh, I'm really, like, in their resume or in their interview, they'll say, I'm really passionate about whatever it is that I'm applying for, right? And then, okay, show me your passion. Well, all I did was my homework. That doesn't show passion, okay? If you go out and you spend, like, your spare time doing something that was never asked of you because you're interested in it, I would say yes, that indeed does show passion, right? Find a data set that's interesting to you, right? I'm sure you guys know about the website Kaggle and how there's all sorts of data sets there. Yeah, you can go on there, find data sets that are of interest to you, you know, or go out and scrape your own data set, find something interesting to you, do a project, and then put that on GitHub. I think that's going to be much more impressive. Okay. All right. So anyway, here's a bunch of links. Okay. First, you're going to have to download and install Git onto your computer. Okay. So if I click this, this is the Git website. You're going to click, you know, the latest version. It probably auto detects your thing. Let me cancel this. And so you'll download this, and then you'll install that. Okay. And then you'll have to go to GitHub to create a new account. Okay. And if you don't have one already, okay? And the way Git works is that you create a repository on your probably what you'll do is you'll create a new repository on GitHub, and then you will clone that repository onto your computer. You'll interact with your repository on your computer, and then you kind of push or upload your changes to GitHub. Okay, so let me write up some stuff here. Okay. All right. So the local version, let me just write, okay, local version, basically you create a repository, all right? And basically a repository is just a folder that Git keeps track of, okay? So in the local version, you create a repository, and then what happens is you do your work and save files locally. And then what you will need to do is you need to commit the changes you've made locally into the repository, okay? So, so the next part is you do git add, okay? And you add the changes that you've made locally. And then you git commit, okay, which commits the changes to the local repository. Okay, and what this does is it allows Git keeps a log of every single change, and so if you ever need to roll back a file to an older version, you can kind of check out the older versions on your computer and stuff. Okay, so that's what happens. Okay, with GitHub, lets you set up a remote repository. Okay, and the remote repository is basically a repository that exists on some server. Okay, so we might just call this the cloud. And so you create a folder, a repository on this cloud GitHub server, and then what you will do is, okay, lets you set up a remote repository. Okay, so first you create a repository on the GitHub server. Okay, and then you will clone to your local computer. Okay, so you clone the repository to your local computer, and then what you do is you make changes and commit them locally, and then you push those changes back to the server. Okay, make changes locally, so then which will be git add, then git commit. Okay, you make and commit changes, and then later to synchronize those changes, the local changes to the remote repository, you git push the changes. Okay, so you get a local thing. Okay, and then what this also allows is that if you go on a different machine, okay, you can push changes to the repository, and then later on, if the remote repository has changed, you can pull those new changes to your local computer. Okay, so you're working stuff locally, and then you kind of push them to the remote, and then if that updates, if the remote repository updates, you can pull those changes to your computer, right? Okay, and so GitHub allows you to also kind of collaborate with others. So they can make changes to the thing, and then and you will pull those changes. You can push changes to the repository, and then whoever you're working with can pull those changes, right? So anytime you need to get the updates, you pull them. And anytime you need to make updates to the repository, you push them up. Okay. And that's kind of the idea. And so so what we're gonna kind of this first week, maybe I should call this homework 0 or something, is you're gonna create a GitHub account and set up a repository and interact with it. Okay, and so we're gonna just kind of do some of the most basic stuff, and then you'll work through the Git assignment on you'll work through your Git assignment on DataCamp, and that will cover things like branching and all of that. And we'll talk about how all of this works. Okay. When you so here's a few important things. So here, let me go ahead and I'll create a repository for our class. Okay. So after I've logged into GitHub, you can create a new repository by clicking this new button. Okay. So I click new. Now I'm going to create a new repository and call this 2019 Fall Stats 131. Okay. And this will be class repository for notes for Stats 131. Okay, and so I will post all of our course notes and whatnot to this thing. Okay, and you guys can get all the course notes. So I'm not going to post course notes to CCLE. Okay, they're going to get pushed to this repository, and you guys can all take a look at it. All right, so I'm going to go ahead and create this. I'll go ahead and initialize this with a README, add git ignore. No, okay. All right, so we'll go ahead and we'll create this repository. Okay, so here we go. All right, so you are going to create a different repository, not this, okay? But you're going to create a different repository at some point, okay? You don't have to do it right now, okay? And then to get this onto your computer, let me see. So right now, I do have. Let me delete this. Let me delete this folder. Okay. And delete this thing. Okay, so I'm going to clone this onto my computer. Okay, so I'm going to click clone, and I'm going to clone with SSH, and it gives me this kind of address or command to clone. And then I have Git installed on my computer, so I'm going to run kind of git bash. If you have a Mac, you can just do this from your terminal as well. Okay, but I'm going to go ahead and go into my OneDrive Teaching 131 folder. Okay, and then I'm going to go ahead and paste this command. Okay, so this is going to clone the 2019. Did something happen? Oh, I'm sorry. Acted git clone. Paste. Okay. All right. So this has now cloned it. Okay. And so on my computer, now I have this folder that I've just created, the 2019 Fall Stats 131. Okay. And so this contains just one thing, the README, the Markdown README thing, which will say 2019 Fall Stats 131. Class repository for notes for Stats 131 here, okay? So in my local computer, I have now cloned this repository. Okay, and so what I can do is I can make changes to this Markdown file and commit the changes to my local repository and then push those changes back to the server. So I've did a clone, and this was done by typing in git clone and then the address of the repository that I wanted to clone. Okay, you should not do this with my repository. Okay, because my repository, only I have read and write access to my GitHub account. Okay, so if you try to clone my repository onto your computer, you will run into problems when you try to push any changes, okay? Because when you try to push them, it will say you are not an authorized user, and it's gonna it's going to create problems. Okay, so so I'll talk about what you can do there. You can fork the repository, but I don't want to get into that right now. Okay, but what you can do is you can just create like a sandbox repository on your own GitHub account, and you can clone that sandbox repository onto your local machine. All right, and so we can just play around. Okay, so here this is my repository. It's just a folder. Okay. So I can just create a new document. Okay, so I'm going to go ahead and create a new text document, and I will call this I don't know, test.txt. Okay. So here we go. All right, and so this is just this is a new file. Okay, and all right, this is a new file. Today is Friday. It is 3:36 p.m. Okay, so I'm going to go ahead and save that. I hit save on my computer, and here we go. Okay, so this is what I have on my local machine. Okay, now if I go to GitHub, okay, it's not there. Okay, nothing has appeared. All right, so what I need to do in Git is I need to enter my directory. Okay, so I'm going to do cd, and then we're in 2019 fall stats 131. Okay, and so here Git recognizes that this is a repository that it's tracking, and it adds on this thing called master. Okay, we're technically on the master branch. Okay, and so I just changed into it by doing change directory. Okay, and so what I can do is I can just kind of on Windows I can type in directory dir. Does ls? Oh, ls also works. Oh, this is called test.text.text. Oh, that's funny. Okay. All right, so I've got this text file here. All right, inside my directory. I also have the readme.markdown. Okay, and I can do git status. Okay, git status tells us what exists in our directory. Okay, and what is being tracked. Okay, and so here under git status, it says on branch master, your branch is up to date with origin master. Okay, origin. This will say the repositories will say this if there's a remote repository that it's linked to. Okay, it's saying your branch is up to date with origin master. Okay, so Git is tracking this, and it says what I've tracked is in sync with what is online remotely. Okay, let me I'm going to just rename this just to be test. Okay, I should have it show things. Okay. All right. If I but here it also says there's an untracked file. Okay, test.txt.txt. I just renamed it to just be test, so it should show up as test.txt. Is an untracked file. Okay, so let me just do git status again. Okay, and now indeed the name is fixed to test.txt. Okay. So it says nothing added to commit, but untracked files present. Okay, so to have Git track this, I'm going to do git add test.txt. Okay. All right, so I tell Git that I want to add this file test.txt for it to track. All right, and then and if I type in git status again, we get the same thing. We get on branch master. Our branch is up to date with origin master, and it says changes to be committed test.txt. Okay, so there's Git always has kind of there's a two-stage process. Okay, you have to add, or what we call you stage your changes, and then you commit your changes. Okay, and this kind of gives you an opportunity to, I guess, change your mind. But it also allows you to separate different changes that you've made. Okay, so for example, let's say you've been working and you've updated 3 different files. Okay, you don't have to commit all 3 file changes at the same time. You can stage them one at a time, and you can stage one change and commit it. You can stage the second change and then commit it, and stage the third change and commit it. And that way, if you need to undo, let's say, just the second change, the middle one, you can kind of reverse some of these things. But you don't. Whereas if you did all 3 at the same time, it's more messy, right? Or they kind of all went in together. Okay, so anyway, we've done git status, and then I'm going to do git commit. When you commit them, you have to include a message that tells you what your commit is about. Okay, so I'm going to do git commit, and I'm going to say added test.txt. Okay, because that's what this change is doing. Okay, so now I've added it. Okay, so what it says is we've added this and we've created this thing. Okay, and now if I type in git status, okay, it says on branch master. Okay, and it says your branch is ahead of origin master by 1 commit. Okay, so it's saying that on my local machine I've made a commit. Okay, my local machine has a commit that doesn't yet exist on the remote server. So right now, the remote server still doesn't show that file showing up, okay? And it's saying that I'm 1 commit ahead, or 1 branch ahead. I'm sorry, your branch is ahead by 1 commit. I'm 1 commit ahead on my local machine than the remote one, okay? So if I want to kind of synchronize this change onto the remote, I'm going to use git push, okay? And it gives you nice little hints, right? It says use git push to publish your local commits, okay? So I'm going to go ahead and type in git push, and via the internet, it pushes all of my stuff, okay? And now if I refresh this web page, indeed, test.txt now appears here, okay? You can technically make changes. This is not recommended, but you can make changes directly on GitHub itself, okay? So I could say this is a new file, today's Friday, and I can say I'll say it is now 3:43 p.m., okay? So I'm gonna go ahead and do that, and I will, and here I'm gonna go ahead and just directly commit the changes, okay? Which says update test.txt, and we'll go ahead and commit these changes, okay? So now the remote repository has a change, okay, that is not yet reflected on my local computer, right? On my local computer, if I open test.txt, it doesn't say that it's now 3:43 p.m., right? So here, I can just ask git status, okay? All right. So right now, it hasn't detected anything, so we actually have to do something called a fetch, and then we commit these changes, or we can just directly do a git pull, okay? So if I do a git pull, it's going to check what's on the internet, okay? And it says, oh, there was a change, okay, and we're going to kind of make these changes, okay? And if I check my file here now, it now has the change that I've made on GitHub, okay? So that's git push and git pull. Now, in order to get this set up, okay, so you have to kind of create your own account, and you have to create your own repository. And when you do, when you try to clone it and all of this stuff, you're going to run into some issues, okay? And what you need to do is you need to go to your account settings, okay? And you have to set up some SSH keys, okay? And what these things are, these are credentials, so your account can talk to, so your account basically has kind of the password and the credentials so that your computer will be allowed to make changes to your repository, okay? And this way it will avoid the problem of you know, some random person trying to I don't know, make changes to your GitHub thing, okay? When you download and install Git for the first time, it might ask you for a password. I don't know if this is best practice, but just my personal recommendation is don't put in a password, okay? Leave it blank for the password for just regular old Git on your local computer, okay? I think you already have a password somewhere before you can even get into your computer, because if you put in a password into Git, every time you type in a Git command, it's going to ask for the password, and it gets old really, really, really fast, okay? Because you're going to want to do git add and git. Every time you do this, it's going to ask for a password. So, so just leave no password on the Git when you install it, okay? Obviously, you need a password for GitHub and all of that stuff, okay? And in order to get it to work, you have to create an SSH key, okay? And so I've linked a few of these documents here, okay? So these are instructions for how you create a new SSH key on your computer, okay? And you're gonna just type in, so when you first create Git and you try to do something locally, it's gonna ask for your email address and your name and all of this stuff, okay? So, but basically, you're gonna do this. You're gonna do SSH keygen and create a file, okay? And this is gonna get saved somewhere in your computer, okay? C users u.ssh. So if I were to navigate on my computer under users, me, and then here's, you know, .ssh, okay? I'm not going to open this, okay? But this is going to have this very long code, okay? And what you're going to do, so once you've generated that, you're going to need to add that to your account, okay? And so this is just the Windows. You can always click the Mac version, okay? And then so once you've oops. Oh, okay. I guess add the SSH to your GitHub account, okay? And so you're going to come to here to SSH keys, and you're going to click new SSH key, and then you're going to you know, in this directory where the RSA key is, you're going to copy and paste. It's going to be this very, very long bunch of jarble of letters, okay? But that's the key that it's going to use, okay? So it's going to use that, and that will allow you to work with that, okay? So so anyway, your homework this weekend, okay? You already have an assignment on DataCamp to work through the Git tutorials, but the other part of your homework is to create a GitHub account, create a repository, and get your SSH keys on your machine set up to get it to talk to the repository online, okay? And so this will be our first step in getting in using Git and GitHub. All right, we'll see you guys on Monday.